Hello everyone and welcome to today's video. In the previous video, I showcased the game Flappy Sats and explained its high score system, earn mode, and score withdraw feature. However, I mentioned that the game lacked security and could be easily manipulated, as demonstrated by David in his recent video. In this new video, I'm taking steps to address these security issues. I will walk you through the changes I have made to prevent such weakness and ensure a more secure gaming environment. These changes aim to enhance the game's overall security, providing a more trustworthy and enjoyable experience for all players. Our first step was transferring everything to Playfab. You should know that you're not limited to Playfab. You can use your game server as well. The primary reason behind these changes was to counter potential hacks, such as tweaking player prefs, manipulating memory value while playing, and reverse engineering by gaining access to sensitive details like API keys. It's crucial to avoid making direct API calls to ZEBEDEE from the client side and to refrain from exposing API keys in your game. This move ensures the security of your game's data and functionality. Let's get started. Firstly, I download the Playfab Unity editor extensions and import the package into the Unity project for Flappy Sats. Once the import process is complete, the Playfab Unity editor extension panel should open automatically. If you already have a Playfab developer account, click on Login to enter your Playfab username and password or create an account. Then select Install Playfab SDK to import the SDK into your project. In the Playfab dashboard, I create a new title called Flappy Sats. Afterwards, I create a new script named Playfab Manager and attach it to an empty game object named also Playfab Manager. Now let's break down the code step by step. In the start method, I set the title ID to the unique identifier for the game project on Playfab. I store it in a variable for easy modification from the inspector. Then, I call the login method to initiate the Playfab login process. If the login attempt fails, the onLogin failure method is triggered, which log a warning message with the error details. If successful, the onLogin success method is called. Regarding the onLogin success method, I'm setting up Cloud Script request. The code creates an instance of execute Cloud Script request used to request the execution of a Cloud Script function on the Playfab server. In this case, the function name property is set to getEarnModeScore, which triggers the execution of the getEarnModeScore Cloud Script function on the server. This function retrieves the max earn score required for the players to unlock the earn mode in the game, eliminating the need to store this information within the game itself. Similar to the login method, this process involves two callback methods, onCloudScript success and onCloudScript failure. In onCloudScript success, I first check if the result is not null. If it is not, I deserialize the JSON response to retrieve the max earn score value. Then I enable interaction with the play button. Moving on, when the bird character avoids an obstacle, the increase and save score method is called, instead of the previous increase score method. The new method triggers the update player score process. Update player score is responsible for sending a request to Playfab Cloud Script to update and retrieve the player's score. The execute Cloud Script is invoked with a request to execute the update and retrieve score Cloud Script function. This function updates the score and high score and then fetch the updated one from the server. Inside the Cloud Script on Playfab, I have implemented update and retrieve score in JavaScript to be invoked from the game client. It initializes an increase amount variable with a value of 1, representing the score increase for each obstacle avoided. The player current score and high score are retrieved from internal data. Increase the score by 1 and compare it. If the current score surpasses the retrieved high score, the internal data is updated with the new values. Otherwise, only the score is updated. After executing the Cloud Script, the updated scores are deserialized from the JSON response within the onCloudScript executed method. The display score and display high score method are then called to present those scores on the screen. The important point here is that the game no longer stores the current score and high score in player prefs within the game, preventing manipulating and altering memory value. Upon clicking the play button, the score is reset to 0 using the reset score method. This method calls the reset score function within the Playfab cloud script, retrieving the current score, saving in internal data, resetting it to 0, then saving it again. In the withdraw panel, when the current score surpasses the max earn score and the earn mode has been unlocked, the withdraw panel is displayed. Upon entering gamertag and clicking the withdraw button, the save gamertag method is called to execute the save gamertag cloud script function, passing along the player's entered gamertag. Within save gamertag, I retrieve the gamertag from the function parameter and store it in the player's internal data. I then retrieve the player score from internal data using server.get user internal data. If the internal data contains a score key, its value is extracted and converted to an integer. If not, an error response is generated, indicating the absence of the score data. The player score is stored as a withdraw amount in the internal data. To send a payment to an external API, the send payment to API function is invoked, including the score, gamertag, and a description. This function interacts with an API using an API key, URL, and HTTP methods. After sending the request and receiving a response, I check whether the payment was successful. If successful, a response object is created with a success message. If not, an error response is returned. In the onCloud script executed data method, I determine whether the response is true. If it is, a congratulations panel is displayed. If not, an error panel is shown. In both cases, the store is reset to 0 using the reset score onStart method, which calls the reset score function within the cloud script. Then I add code obfuscation to ensure the security of the game's logic and prevent reading, especially when examining the code source using external software. This involves using a Unity asset known as obfuscator. After integrating this asset into the Unity project, I navigate to the obfuscator option and configure a few parameters. Specifically, I check public mono methods and obfuscate string literals. Additionally, I add the script rename approach with the button click method, such as play button method. Now, the code becomes much harder to understand after applying these steps, making it more difficult to hack it. In the next video, we will look at more advanced ways to stop Charles proxy attack of repeating the hit obstacle function. Thank you for watching. See you in the next video.